In the previous video, we covered lab number 5 in the SQL Injection module, so we got some hands-on experience by exploiting a union-based SQL injection in order to extract the usernames and passwords of the users of the application. In today's video, we'll be using a union-based SQL injection attack in order to retrieve multiple values in a single column. If you do not have an account on the Web Security Academy, you can get one by visiting the URL portswigger.net/websecurity and clicking on the sign up button. I already have an account and I am logged in, so to access the lab, I'm going to click on Academy, go down, select the learning path, select SQL Injection, select Union Attacks, and today we'll be covering the last lab, which is this one over here. So SQL Injection Union Attack, retrieving multiple values in a single column. All right, let's get started. This lab contains a SQL injection vulnerability in the product category filter. So we've got SQL injection, and it's in the product category filter. The results from the query are returned in the application's response, so you can use a union attack to retrieve data from other tables. We already learned how to exploit union-based SQL injection in previous labs. The database contains a different table called users with columns called username and password. To solve the lab, perform a SQL injection union attack that retrieves all the usernames and passwords and use the information to log in as the administrator user. So the end goal over here is to retrieve all usernames and passwords and log in as the administrator user. This lab provides us with a hint over here. We're not going to look at it just yet. We'll revisit this section over here when we're working with the lab. Okay, let's access the lab. Okay, let's create an analysis section. All right, so it looks like the same shopping application that we've been dealing with in the past couple of exercises. If we click on, for example, lifestyle, it'll filter based on the products that are related to lifestyle. And we'll see over here that it filters based on a category parameter that is in the URL. So that's the parameter that is vulnerable to a SQL injection vulnerability. Okay, so the first thing to do to confirm that it is vulnerable to a SQL injection vulnerability is to inject it with a SQL character that could potentially result in a syntax error, which could result in an internal server error at the application level. Okay, so now I'm convinced that this is vulnerable to SQL injection. Now, since the results are displayed on the page in at least one column, we could use union-based SQL injection in order to output content from other databases. And to do that, we said the first step would be to find the number of columns that the vulnerable query is using. And to do that, we'll use the order by clause. And we'll iteratively order by each column until we get an internal server error. If we get an internal server error, that means we're ordering by a column that does not exist. And so it gives us an indication on the number of columns that are being used by the vulnerable query. So we'll start off with 1. And we don't get an internal server error, which means that this column exists. And notice over here that it didn't actually order this column, and so this is not column 1. Column 1 is a column that is not displayed on the page. And so since it's not displayed on the page, it won't help us in terms of displaying usernames or passwords. So let's make a note saying not displayed on the page. Next, let's try with column number 2. Okay, so column number 2 definitely exists, and it's this one over here because you'll see it order the alphabets. So we'll make a note over here, displayed on the page, because that's a column that we can use in order to output data from other tables in the database. Okay, let's try with 3. And we get an internal server error. So what that means is we're trying to order by a column that does not exist, and that's why the application threw an error, which means that the number of columns is 3 minus 1, which is equal to 2. And we know that the column that is displayed on the page is 2, and so that's the one that we'll be using in order to output data on the page. So the second thing that we said we have to do in a union-based SQL injection attack is to find which columns contain the data type text. And the reason behind that is because when we're outputting usernames and passwords, we're outputting content that is of type text or of type string. And so we need to output them in columns that accept types text or string. So to do that, we said we use the union operator and the select statement. We know that we've got 2 columns based on this. And so instead of having null null in both columns, we start testing each column out to see if it accepts the type string. So in this case, A. Now, testing the first column is not really useful because it's not outputted on the page, and so we can't actually use it. But let's try it out either way. So we get an internal server error, which means that the column does not accept data type text. Let's try with the second one. Okay, and we could see A over here, which means that the second column accepts data type text, which should have been obvious from the beginning because you could see over here that it has alphabets in the column. All right, so this is our column over here. I'm going to put 2 stars. So the third step is to output data from other tables. And in this exercise, we're interested in a user's table, and we want to retrieve the usernames and passwords of the users of the application. Now, we run into an issue over here, and the issue is the fact that we only have 1 column in order to output data in, but we want to output data from 2 columns, both the usernames and the passwords column. So what we could do is output each column at once. So union select null for the first column, and then username from users table. And what that will do is it will output the username entries from the user table in column number 2. Here we go. We could see administrator and Carlos and another user right over here. And then in order to output the password, we run the query again, except we output the password over here. You could see over here, it's outputting the passwords of the users of the application. Now, I don't want to do this in 2 separate queries. I want to be able to output both the username and the password in the page all at once in 1 query. And the way to do that is by using certain payloads. And we'll look at the hint section over here that was provided in the exercise. So you've got over here string concatenation depending on the database that you're working with. And what that is being able to concatenate several strings into a single string. So in Oracle, that's the way you do it. In Microsoft, that's the way you do it. In MySQL, that's the way you do it, and so on. So we'll use that in our exercise. However, we don't know the database that we're working with. So we first have to figure out the database before we know how to concatenate strings together. And to do that, if you go down, you could use the database version command, and then based on that, you can tell what database you're working with. So let's start off with Microsoft. So it would be over here. And it's no longer from the users table. Okay, and we get an internal server error. That means we're probably not using the correct syntax, which means that we're probably not dealing with a Microsoft database. So let's try with PostgreSQL. So the syntax for that is version. Here we go. Okay, so it outputs the version of the database, and just because the payload or the command that is used in order to display the version of PostgreSQL databases, now I know that I'm dealing with a PostgreSQL database, and I know the exact version as well, which is good information to know. So I'm going to copy that and put it over here. Now, the reason we wanted to know the exact database is to figure out how to concatenate strings. So if we go up, that's how you do string concatenation in PostgreSQL. So our new command would be select null and then username, and then what is the two bars or the OR operator password from the users table. And this should output both the username and password into a single column. So let's try that out. And here we go. So it shows that it's outputting the username and password, but I don't know where the username ends and where the password begins. And so what I'm going to do is add one more string. So a character that I know is an added character. So let's say a star. And this way it will place a star between the username and the password. And let's try that. And here we go. So you've got all the users of the application, and now you can tell which is the username and which is the password. So let's save that over here. Okay, so the end goal was not just to display all the usernames and passwords, but to actually log in as the administrator user. So let's do that. So username is administrator, and the password is the one that we just found over here. So everything after the star character. Click on login. And it says, congratulations, you solved the lab. So we successfully completed the exercise. All right, the next step is to script it. And to do that, we always start by importing the request library. This is a library that will allow you to perform get and post requests. Next, we'll import sys. And URL lib3. And then I'm going to add this line over here. to disable any insecure warnings. Okay, let's click on View, Toggle Word Wrap. All right. Next, we set our proxy setting. And that comes in really handy when you're debugging your script if it doesn't work. Okay, and then HTTPS. One 127.0.0.1 8080. So what this is going to do, it's going to send all the requests that the script is making through burp first before it sends it to the application. And then any responses from the application get sent through burp first before it gets sent back to my script. And we'll see how this comes in handy in a bit. Next, we'll create our main method. So if name is equal to main, then we've got a try and except clause. So the way I want my script to run is I've got script.py and then it takes in the URL. So I'm not going to perform step number 1 and step number 2 in the script because that's going to take me about 30 minutes to do and we've already done it in previous labs. So instead I'm going to assume we already know step number 1 and step number 2. So the number of columns and the column that accepts text. And I'm just going to perform step number 3 in the script. I'll leave it up to you as an exercise in order to be able to integrate all 3 steps in one script. Okay, so it takes in only one command line argument, and that's the URL. So we'll save that in a parameter called URL, and we'll take that from the command line. If you give it the incorrect number of command line arguments so it doesn't find the URL, I don't want it to print the exception. Instead, I want it to print the usage and example instructions. So let's say usage, name of the program, the URL, org fee 0, and then the example instructions. So let's say www.example.com, and again, name of the program. Okay, and since I ran it incorrectly, I want to exit it. All right, so that's what happens if you run into an exception. Now, assuming that you ran it correctly and it saves the URL in the URL parameter over here, I want it to print dumping the list of usernames and passwords. And then we're going to create a function called exploit SQLI users table. And it takes in the URL parameter over here. And then if this function outputs false, so returns false, print did not find an administrator password. Okay, so we're going to implement this function right now. And again, takes in the URL. So we said we're making a few assumptions that we know the username that we want to output is the administrator username. Next, we need the path to the vulnerable parameter. And to do that, we can get it from the URL, but we're going to need burp anyway, so let's open it up right now. Click OK. Close, next, start burp. Okay, notice over here my proxy settings is the same as the one that I set in my script, and this is why the script is able to send the request to burp. I also need to configure my browser to send the request to burp, and I do that using an extension called Foxy Proxy. So I'm going to click on intercept over here, click log out, and notice over here it intercepted my request. So I'm going to set intercept off and work from the history tab, and this turned off, so sorry, this timed out. So let's open a new one. And we no longer need this one over here. Okay, let's click on pets. And here we go, that's the path to our vulnerable parameter. So let's copy that. Put it over here. Next, we want our SQL payload. And we'll get that from our notes document. So it was this one over here. And then I'm going to make the request. So we're using get because it's making a get request over here. And the URL is going to be URL plus, sorry, the URI is going to be the URL plus the path plus SQL payload. I'm going to set verify to be equal to false because I don't want to verify TLS certificates. And then proxies to be equal to proxies because I wanted to send the request through burp. Next, I'm going to save the response in a variable called res. And then I'm going to say if you found the text administrator, so the string administrator in the response, then I want you to print found the administrator password. And then I want a way to extract the administrator password from the response code. And so to do that, I'm going to import two more libraries. So from BS4, import beautiful soup. And we'll use that in order to parse the response. I'm also going to import RE, which allows me to use regular expressions. So let's see how the username and password are displayed in the response. So to do that, let's take this again, copy it, and run our attack one more time. Okay, looking at burp, we see, here we go. All right, so you've got administrator, star, and then the password of the administrator user. So to extract that, I'm going to parse the response using the beautiful soup library. So r.text and use HTML parser. And then I'm going to say the admin password is equal to soup.find, so my variable over here. And I'm asking it to find the text that is equal to this regular expression over here. So dot star administrator and again dot star. So a string that contains the string administrator in it. And then I'm going to split that string on the character star and extract it. Okay, so what this does is it finds this string over here and then it extracts the second argument based on the star. So you've got the star over here. So this is argument number 1, which is in an array considered as index 0. And then what I'm interested in is not the administrator username, but the password. And so I want to extract the second argument, and in an array that would be index 1. Okay, once I've extracted it, I want to print it. So print the administrator password is, and we'll add it over here. So admin password. So the variable over here. And then I'm going to return true. Otherwise, I'm going to return false. Okay, let's save that. Okay, so what this does, oh, we've got a mistake over here. Here we go. So what this does is it's going to print dumping the list of usernames and passwords. Then it'll run the function exploit SQLi users table. If it finds the administrator string in the response of the SQL injection attack, then it'll print found the administrator password, and then it'll print the administrator password is so and so. Otherwise, it returns false, which ends up printing did not find an administrator password. Okay, hopefully this does not have any mistakes in it. Let's save it and run it. So Python 3, SQLi, lab 06.py, and let's grab the URL. And run it. Here we go. It ran in the first try, which is great. That means I didn't make any errors. All right, so it says dumping the list of usernames and passwords. Let's look at burp. And then it makes this GET request over here. It looks for administrator. It finds the administrator password and then it extracts it and it outputs it over here. So this one over here. All right, so we've successfully completed the exercise. To recap, in this video, we first manually ran a SQL injection attack in order to retrieve multiple values, so the usernames and passwords of the users of the application, and output them in a single column. We then scripted that exploit so that it automatically does that for us. In the next lab, we'll learn how to exploit a union-based SQL injection vulnerability in order to query the database type and version on Oracle.